let's look at the sigma notation, guys. And you can see on the board this little notation here, or a little symbol here that has this. It's called a sigma notation. And what the sigma notation implies is the summation of all the different scores that we have to sub in. And you can see that the scores, the points that we want to sub in is from the points on the bottom. So you can see the number here. See how I is 1? We want to know the sum of this expression here. So a sigma notation always has a formula or an expression that follows it right on the side of it there, on the right hand side. Now that's going to be the formula we're going to be using. In this case it's ti. And see how there's an unknown value I? Well, what we have to do is start from what's on the bottom here. It's got 1, isn't it? So we start from subbing in 1, and then 2, and then 3, and then 4, all the whole numbers that start from this number up to the number that we have on the top of the sigma notation. So if I rewrite this without the sigma notation, my summation will start off with T1, because see how I start with 1? So I subbed in 1 into my I. So that Ti becomes T1. Now, as I said, sigma notation implies sum. So now I have to add the next one, which is T2. So the next whole number up from 1 is going to be 2. So I replace the I with a 2. So it becomes T2 now. So then what do you think the next one would be? Plus T3. And then blah, 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 all the way to Tn. Because we don't know what n is. N could be anything. So we want to go all the way up to n. So it's going to be, you can see that's going to be T4, T5, T6, all the way up to Tn, whatever the n is. So that's what our sigma notation implies, guys. So if you see that little symbol, don't worry, all you have to do is do the sum. Now, we'll try some questions, guys, starting with question 1. You can see that we've got the sigma notation here. And they give us a little formula on the side of it. In this case, it's 2n. Now, the unknown value is n, and it tells us on the bottom of the sigma notation that n will be 1. So we start from subbing in n equals to 1, then n equals to 2, and then you can see that our final one of n is going to be 3. So the final n will be 3. So this is what's going to happen. I'm going to start off by subbing in the n with 1. So I replace the n with 1, because remember, we start with 1, n equals to 1. And then we add the next one, 2 times 2. See how I replace the n with 2 this time? Because the next number after 1 is 2. And then we'll do another one, plus 2 times 3. So I replace the n with 3. So it's 2 times 1 plus 2 times 2 plus 2 times 3. And we don't have to do anything further, guys, because look, on top of the sigma notation, it tells us it's 3, which is the final one that we will substitute. That's it. So we can simplify. It'll be very simple. 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6. Add it all up, guys, and you'll get 12. So that will be the value of our sigma notation, what it asks us to calculate. So the sum of it all. So focus on what we're starting with and focus on what we're ending with. That's also very important, because you might go, so you don't end up going too further ahead. So we'll go into question 2, guys. Again, you can see that the formula that we have, the expression on the side of the sigma notation, is n plus 2 in this case. And we start from when n equals 2, 5 this time. It's not 1. So it's not always starting with 1, guys. So that's why you have to keep an eye on this. So n, we start with 5, and then we want to go all the way up to when n is 8. So let's try it. All I have to do is first sub in when n equals to 5. So see how I replace the n with a 5, so it's 5 plus 2, and then plus, we're going to sub in the next one, which is 6. So I replace the n with 6 this time, so 6 plus 2. Keep going. The next number up is 7, so I'll do 7 plus 2 this time. And then the next number up is 8, so I'll do 8 plus 2. So you can see that we're doing 5 plus 2, 6 plus 2, 7 plus 2, 8 plus 2. And can we stop there, guys? Yes, of course we can, because look at the number on top of the sigma notation. It's 8. So we stop when n is 8. And that's the last one. So now again, we have to simplify it. I've just simplified a little bit. 5 plus 2 is 7, 6 plus 2 is 8, blah, 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 blah. I just simplified it. And then add those 4 numbers up for me, because again, we have to do sum, don't we? So always remember it's sum with sigma notation. And you'll get an answer of 34. So that's just our value of the summation. So be careful when you're actually calculating it though. Alright, let's go to question 3. You can see that the expression on the side of the sigma notation is 2n plus 1. So again, we do the same thing. You can see that we're starting with n equals to 1, and we're going all the way up to n equals to 50 this time. So it's going to be quite a large series, isn't it? So let's still try it. We'll start with n equals to 1, so I replace the n with 1. And then next, next one up would be when n is 2. So I replace the n with a 2. Yeah, so it's 2 times 2 plus 1. So all I'm doing is replacing the n. And then 2 times 3 plus 1. So we replace the n with 3 this time. So it's 2 times 1 plus 1, 2 times 2 plus 1, 2 times 3 plus 1. And you can see that's going to be 2 times 4 plus 1, 2 times 5 plus 1, etc., all the way to 2 times 50 plus 1. See the number on top of the sigma notation, guys? The last number that we want to substitute is when n equals to 50. So I replace the n with 50, and I don't want to actually write the whole list out. It's going to spend too much time. So instead of writing everything out and having to manually calculate everything, what do you guys think we should do? What do you think? Well, this is a series, and we are going up in an arithmetic progression. So what we're going to do is, I just simplified it a little bit just for your reference, just so you know that it's going to be arithmetic. See, 2 times 1 is 2 plus 1 is 3. 2 times 2 is 4 plus 1 is 5. 2 times 3 is 6 plus 1 is 7. And you can see the pattern, right? And then the final one, 2 times 50 plus 1 would be 101. So guys, can you see that arithmetic progression that I've mentioned? See, 3, 5, and 7. The common difference is 2. 3 plus 2 is 5. 5 plus 2 is 7. So that's the common difference. So we know it's going to be an arithmetic series. So why don't we now just use our arithmetic series formula? Because we want to find the sum, don't we? So we have to use that sum formula. Now, in this case, guys, we know what the first term is. Remember how we call the first term A? So the first term A is going to be 3. Now, in this one, I know what the last term is. The last term is 101, isn't it? So if we know the first term, if we know the last term, we'll use our formula. Oh, and by the way, n equals to 50, of course, because there's 50 terms. We're starting from 1 all the way to 50, so there's 50 terms. Just keep that in mind as well. So, back to our arithmetic series that I was talking about. We're going to be using a formula where we use the first term and the last term. Remember, n over 2, a plus l? That's what we're going to be using. And we'll just put everything in, and we'll get a value like this. See how n is 50, a is 3, the last term is 101. And just calculate it, guys. You should get 2,600, as simple as that. So when you get a really, really long long sum, see if it's arithmetic or even geometric if you can, but just check, and then we can use some formulas to simplify it easily. Alright guys, so that was question 3. We'll try another one, question 4. Now it does look very, very similar to question 3 because on the side of the sigma notation we have the 2n and then the plus 1, but the only difference with question 3 and question 4 is that the brackets are only around the 2n. Remember in question 3 it was 2n plus 1, the whole thing bracketed, but this one the only brackets are in for the 2n, which means only the 2n applies for the sigma notation. So that sum form is only for that 2n. So after we do this summation, at the end we'll just add 1. Okay, so the plus 1 is not part of that sigma notation. Okay, it's not part of the sum. Just keep that in mind. So you have to be aware of where the brackets are indicated. So that's very important. But anyway, other than that, we'll just do the same thing. So what we're going to do is just kind of just put your hand over the plus 1 and ignore it for a while. And let's just focus on the 2n. And you can see that we start with 1, when n equals to 1, all the way to 50 again, like in question 3. So I'm going to start by subbing in 1 into the n. Plus, next one will be 2, so 2 times 2. The next one will be 3, 2 times 3. The next one will be 4, and you can see, and then the last one is, of course, 2 times 50, where the last one, see how on the top it says 50? So that will be the last one. Now, the plus 1, we'll just add it at the end. Okay, guys? So that's all you need to do. So just ignore it for a while, and just at the end, we add 1. So, again, excluding the 1, you can see that this part is how I expanded that sigma notation using sum. Let's simplify it down a little bit. 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, and you can see the pattern, and then 2 times 50 is 100, and I've just got that plus 1 at the end following. Now guys, can you see something, guys? Is it a pattern again? Can you see that pattern? 2 plus 2 is 4, 4 plus 2 is 6, and therefore, because the common difference is 2 each time, it is also an arithmetic progression. So what I'm going to do is say that the first term is 2, that's the first term of my arithmetic series. The last term, again, I know that it's going to be 100. And the number of terms is again 50 because it's from when n equals to 1 all the way to when n equals to 50. So n is going to be 50. So let's put it into our arithmetic series formula. You remember the first term plus last term formula? That's what we're going to be using. So put it in. So I've got 50 as my n. First term is 2, last term is 100. And of course, guys, I've got my plus 1 following at the end. Just add that at the end. So just calculate it all, and then you should get 2,550 and then plus 1. I'll just add the 1 right at the end. So it becomes 2,551. Alright guys, so again, keep an eye on where those brackets are.